Hello, my name is Ian Neal, and I'm the creator of a digital humanities project called the Codex. And I'm going to walk you through a little of what Codex is and what you can do with the system. So, the purpose of Codex is to deeply integrate text and data. And what I mean by that is I want to be able to extract entities from the text, such as people, places, works of art, uh, concepts, events, and to anchor them in back in the text, in the primary sources. So the focus of this talk will be on historical texts, being the letters of Michelangelo, and possibly we'll look at the diary of Luca Landucci. But as a whole, Codex can handle any kind of text of any practical length. So a couple of years ago, I debuted a version of Codex which was very much based in a graph model and which had less emphasis on textual annotation. So it was conceived of as a way of mapping historical events from primary sources. So it was typically built around a timeline. And the idea was to visualize connections between people, places, concepts, and events that were mentioned in these texts. And as we can see by the word, well, what I call an idea cloud below, because it encompasses more than single words, it's kind of like a subject map, or not quite a topic map in the technical sense, but this was a kind of conceptual mapping of the subject matter of um, the historical text I was working with. But what the system lacked was a way of connecting the Neo4j graph database entities back into the text. It was done in a very, very, very low resolution way, in a very basic kind of markup. So in the meantime, I decided that I wanted to be able to map in a much more fine-grained way, and I explored the options that were out there, including XML. But an issue I ran into very quickly was the difficulty of doing overlapping elements in XML. And this seemed to me a problem because I would be wanting to overlap events which could take place over sentences or paragraphs, and people and places and other things inside that. And so there was the potential that there would be elements in XML that would come into conflict. And I did some reading into it, and I discovered a paper by Desmond Schmidt on from the University of from QUT in Brisbane, who talked about the idea of standoff properties. And this is something that I wanted to explore in 2017, but I couldn't quite work out how to bring the concept of standoff properties into a text editor environment where you could make changes to a text, deleting characters, adding characters. Because the idea of a standoff property is that on the one hand, you have the raw or plain text stored somewhere in a file or in a database, and the annotation markup is stored separately and references that text by character indexes. So if there was a particular sequence of characters which is bold, from say the 5th character to the 10th character, you would store that that range, 5 and 10, and then the type of the annotation. The problem with this is if you start to make changes to that document, you are forced to recalculate those indexes. But in 2018, I came up with a solution in the browser that would eliminate that problem and allow you to freely edit texts without invalidating standoff property indexes. So this brings us to 2019, and the state of the art with Codex is that it's aiming to achieve this deep integration of text and structured data. It's done by managing standoff property documents linked to graph entities via these annotations. Now, the editor that's used, which is being nicknamed Speedy, the standoff property editor, is a self-contained vanilla JavaScript module with no dependencies. It's so self-contained that I've published it on GitHub as its own repository, and it can be used with any project, with any kind of database. It accepts a JSON object and returns a JSON object and has no concept of a graph database or NoSQL. It doesn't even really have a concept of specific annotations, and this makes it very easy to extend it. Annotations are programmed into the editor via configuration by the code which makes use of the editor module. So it's very straightforward to add a new annotation to the system, and to add lots of special features even as well for handling specific scenarios around annotations. So we're now at the point where the text annotations are high resolution, and because overlap is very straightforward, they are multi-dimensional, which means, as we can see in this screenshot here, we have a number of overlapping colored lines, which is a representation of the annotations on the top right row of buttons here. The color of the line corresponds to the button and the annotation. And because these overlaps are so easy, it makes it fairly straightforward to build multi-dimensional texts. So I explained before briefly what a standoff property is, but I'd like to talk a little bit more about what it enables within a text annotation editor. The first thing is that all of the text is kept in a plain format, which is at this point whatever UTF is built into JavaScript. I think it will support UTF-16, but I'm essentially treating it as UTF-8 at this point, and whether I go into full Unicode support is a question for later. But basically, you can think of it as being raw text, which has the virtue of being easy to read by humans and by machines, such as search engines, database searches. You don't have to worry about embedded markup breaking the sequence of characters. Now, standoff properties can be as long or as short as you wish. They can overlap, which means that you can annotate inside words and the word is still preserved in its raw format. You can annotate single characters. You can even place an annotation between characters, which I call a zero width annotation. Standoff properties don't suffer from the XML overlap problem because they are non-hierarchical property indexes. You can have as many as you like, and they're not encapsulated in a kind of tree structure like XML. One implication of this is that you can treat these properties as layers, or as I prefer to think of them, as strata, and this has a number of possibilities. So one is that you can import or export a given set of annotations that are grouped together into a layer. Those annotations could be, for example, annotations belonging to a certain user. So you could say, I want to load, Bob's annotations, or I want to exclude Bob's annotations. You might want to import a bunch of part of speech token annotations, or you might want to exclude them from your editing session. The other possibility is that this layering translates into multi-dimensional database queries, because you can look at regions. You can look at regions of text where multiple standoff properties overlap, and because these properties, these annotations, contain meaningful information, you can essentially extract more meaning from these overlaps. And one example of that, which I'll demonstrate, is treating parts of speech tokens or a syntax tree as its own stratum, where that can be thought of as being something which underlies your text, and which you can tap into at any point and query the system for finding connections between words and annotations which also overlap those parts of speech. The other aspect of the system is the graph database entities themselves. And there are many that we have access to in Codex, and you can add more or take away as you see fit. But the core entities that I've found that I use frequently are text themselves, which are text nodes in Neo4j, and standoff property nodes, which are linked to the texts. Those standoff properties not only mark up or annotate the plain text, they can also be used to link within the graph to other entities in the system, such as agents. This is a slightly controversial term. It's a term which grew out of the origins of Codex as being a historical database, and I thought of historical agents, beginning with people and then organizations and so on. But I tend to use this term to mean any kind of entity. So you could think of an agent as being an entity. Typically an entity which is mentioned within a text. And it could be something quite specific and concrete, a person, a place, a work of art, a building. It could be something a little bit more indistinct. It could be someone referencing a group of people, those people over there, or right-thinking kind of people. Now, that's in my system. I encode that kind of reference, as a distinct agent, because I want to capture every possible nuance I can from the text to see what can come out of computational analysis down the line. And if it's an entity in the mind of the author, it's essentially an entity in this system. We then have the next important concept is that of meta-relations. Now, these are basically relationships or edges between nodes and other nodes, but it's taken a little bit further as being relationships treated as a graph. So on the one hand, they're relationships which the user can define inside the Codex interface. And the idea is that as you're working on the text and you see a kind of relationship that's not already offered in the system, something you would like to capture, some nuance of a relationship, you can easily go into a screen, you can create that new relationship. The other aspect of it is that it's created in a bidirectional way. So you don't have to worry about, oh, okay, well, I've got a parent relationship, a child relationship, for example. I must pick one or the other every time I want to use this, because vectors or edges in graph databases are directed, and you have to pick one direction or the other. In this concept of a meta relation, you define the concept of a relation of, to take parent and child, you would take the concept of parenthood, which has a parent relationship and a child relationship. In this system, they're called a dominant and subordinate, and it's up to the person defining the relationship to nominate what they think of as being the dominant party in that relationship. So one might say maybe a parent is the dominant party and the child is the subordinate party. But essentially the meta relation, which is expressed as a hypernode, allows you to capture this directionality. The last aspect of this is that because the relationship is expressed as a hypernode and not as a direct link between nodes, you can situate that within its own graph, its own ontology, its own hierarchy. So you might start by creating a very concrete kind of relationship, like you might say friend of. So X is a friend of Y. And then you might say, well, in the text that I'm working in, the author uses many different kinds of, mentions different kinds of friendships, acquaintances, correspondence, close friends, intimate friends. And to be accurate, you would want to capture those. So you have the option of creating as many specific kinds and then creating a hierarchy above that. So one could say all of these different kinds of friendships are under the heading of friendship. And you can imagine doing that for professional relationships, employee, employer, collaborator. And this will feed into the computational side of the system down the track, where you could expand your queries to say, rather than looking for specific friend relationships between two people, you might say, I want to find every kind of social connection between this person and anyone else connected to them. And that's where the meta relation graph comes into it. The next entity is what I've called statements, and it's quite a broad concept, but basically it's essentially a kind of RDF idea of it's a kind of quasi-grammatical construct. You would say essentially X does something to Y at a place at a time, but it's quite a fluid construct where you can have any number of agents who are connected together in a kind of cluster, and you nominate essentially what it is that they're doing. It could be an event, or it could be a statement of identity, or I should say of ontology. You might say it might be a statement about a trait that a person has. And finally, you have the concept entity, which could be thought of as simply maybe a class. It's simply a key value structure which can be organized into a hierarchy, in which most of these other entities can refer to. It's not an ontology as such, like Cydoc CRM. It's simply a user-defined hierarchy which is used to provide context for the other entities above. So why don't we take a look at a text in the system. So here we are on the text search screen in Codex, and I've pre-filtered this to the Michelangelo corpus under the section heading. Texts are not limited to any particular format or type. It's simply, you can imagine as being like a file. In this case, it's stored in the database, but there's nothing to say what a text is. It's whatever you want it to be. In this case, these texts are letters, footnotes to letters, endnotes, and such. So we're going to look at a particular letter, one of Michelangelo's last letters, to his nephew Leonardo di Buonarrota Simoni, and we'll look at the editor and we'll come back to this screen in a moment to show some of the things that we can do with the annotations that we've applied to this letter. So first of all, it's a fairly busy interface, but it breaks down to a couple of sections. We have our annotation buttons, and these are divided up into categories. We have our editor window, which you can resize. You should be able to resize. There we go. And you have a section underneath which I call the monitor, which is a visualization of the standoff properties or annotations which intersect the cursor position. So you can see this blue line here corresponds to that blue underlined annotation there called a claim. And if we mouse over the other annotation labels here, the corresponding annotation will light up. Now the reason why this one lights up is that the start and end of the attitude derogatory annotation encompasses the cursor position where we are, so it's picked up and displayed here. This is, you can see here, it's a kind of an overlapping annotation. We've got the whole page as well. You can see we have various sort of stylistic annotations, italics, superscript, and then we have these semantic annotations which are rendered as, in whatever form you like. They're CSS style sheet classes which are applied in the editor. They're all defined externally in your own code. Now, one thing I want to show straight away is how the system can fairly easily handle overlap. So we'll just show what that might look like. So we'll just do some overlapping annotations here. So we have strike through, bold, and bold strike through. We also have the ability to edit the annotation. We can delete it. We can assign a layer to it, a name. We can add a comment to the annotation itself, which will be an entire text editor instance with all of the capabilities of this editor. And we can move that annotation back and forth. So I'm moving the bold annotation around. So if you happen to misalign something, you can correct it fairly easily. You can move it left and right, and you can expand it, and you can contract it as well. And we can do the same with strike. Let's separate them. We can delete them. We'll just refresh. We also have a new type of annotation that I've put into the system is what I call a block. It's a kind of presentational option. You can now apply alignment, left, right, center, indentation. There will be more capabilities with that later, but it's not essential to necessarily to have that kind of alignment, but for the meaning of the text. But it's nice to have that, to be able to match it more closely to the source. We have a lot of options here, but one thing we might want to look at is how the system can manage with insertions and deletions and so on. So we could easily start to insert, we can delete, we can even delete across annotations, and it makes some intelligent guesses as to what we would want to do. And the system has no problem with this. It's not slowed down at all. All of the magic happens at the point where you save the document. The standoff properties are connected to the text via object pointers. There are no indexes while you're working on the text. Indexes are calculated at the end. And this is a fairly quick operation which we can test by clicking the unbind button, which is most of the time practically instantaneous. And we see here we have the raw text, and then underneath we have an array of properties with information about the standoff, about the annotations. We can have lots of different kinds of annotations. We've looked at some fairly basic stylistic ones. We have access to annotations which might have attributes. So I was curious to see if we could represent the TEI annotations in the system, but to do so I needed attributes, because that's an aspect of XML elements. So now you can have and set attributes on annotations, and you can freely mix annotation ontologies. So the system has no problem with having annotations connected with TEI or my own custom Codex annotations or stylistic annotations. It's up to you what you want to include. Now, these colored lines by convention refer to entity annotations. These are entities in the Neo4j graph database which are linked. So if we click on this, for example, we get a pop-up window which shows you the entity that's referred to by that annotation. And we have a number of options here. We can do a full search of the system if this was the wrong entity. We can add a very brief version, a quick add feature. So when we're working on the text, we can immediately add a new person. We can see entities that were recently added in order from the most recent to least. So we can reuse something that was recently added. And we have a number of other different kinds of entities which might be worth going into separately, as they have their own capabilities. Now, one thing that might be worth looking at is the NER integration, named entity recognition integration. So I'm going to delete an annotation or two. And I'm going to run NER, which will submit the plain text to Google's Cloud Natural Language Processing API. And it will come back with a bunch of underlined words representing annotation candidates. So these candidates are names that the Google NLP library has suggested, text which it suggests are names, and it hasn't attempted to identify who these entities are. I've done that. There is an option to do that in the Google NLP API, and it will attempt to identify an entity in Wikipedia. But given that the text that I'm working with, in this case Michelangelo's letters, refer to a lot of obscure people who are not ordinarily in the historical record or in Wikipedia, or who are mentioned by first name. I rather than do that, I have other facilities within Codex to help identify these entities. So, but what it's done is sort of helpfully underline, at least, so we can see who needs to be linked to someone in the system. So if we click on Leonardo here, the problem is we see a whole lot of Leonardos, and it's picked up any reference to Leonardo. And because Codex is quite broad in its understanding of what an entity or an agent is, you don't just get a list of people, whose first names are Leonardo. You get a list of entities which might have the word Leonardo in there. So one way we can, if we don't know exactly who we're talking about here, one thing we can do is click the aliases button, and this will leverage the standoff properties in the system, and we'll try and find any annotations, any agents which link to the text Leonardo in their texts. Now, if we scroll down, it's getting a little bit more meaningful. So we start to see Leonardo Buonarroti Simone, excuse my Italian, and this is the brother of Michelangelo, so not his nephew. And then we get to Leonardo di Buonarroti Simone, to Leonardo of Buonarroti, which is Michelangelo's brother. So this is his nephew. So we would select that entity, and we see it turns grey. This is to make obvious that the annotation has been selected. Now, if that particular text is repeated throughout, once you've linked it to an entity, you can click the Find and Replace button, and it will update every other link which has the same text. Every other Leonardo will get that ID, and if it's not correct, you can go through and you can delete the ones that aren't correct, and you can go and find them individually. But it's a little shortcut that comes quite in handy dealing with pronouns. So we've assigned a Leonardo. We can see it's taken there. We deleted before the thou, and we're going to put that back in. So I'm going to click the pronouns button, and it's taken that text, it's submitted it to Google, it's come back with suggested pronouns in the system. And in this case, you see it doesn't suggest ones which have already been assigned. So that's more accurate than the name entity recognition window. But so we'll click thou, and there's going to be a lot of thous in the system. We can 1,000. We can try aliases, but there's going to be a lot of aliases with thou in there, not to mention a lot of actual thous in the system. So one other aspect I've built in is, rather than searching the entire database or having to go somewhere else, we can make the assumption that if you have annotated a person, an entity already, the pronoun is going to refer to somebody in that text, someone you've already annotated. If it doesn't, that's fine. You can go and search for them, or you can go and add them. But by default, it'll take you to the inline tab, which shows you the agents who are inline to this text. And if we scroll down, we can see indeed that Leonardo di Buonarroti Simone is one of the mentioned agents, and we can click select. He turns grey, and we can click accept, and we're good to go. Now I'm going to reject that particular change because I've made some corrections, and we're going to look at the text window with its computational options. The first thing I should point out is the versions tab. Every time you save a text, a copy of the previous version is stored in its original format all the way back to the beginning. In fact, if we click iteration 0, we can see a very basic marked up version where I've just put the text in and just started to put some very basic stylistic annotations in, and we can go through to any point. If you want to revert to any version, you simply hit save again, and that version that you're in currently becomes the latest version. So you can always go back, you can always select a previous version. We have a number of other windows here, a few other tabs here. The most interesting ones are probably these two, which we'll look at. So the Agents tab shows you a chart of the agent annotations, so the red underlined annotations. And so we see Leonardo da Buonarrota Simone, Michelangelo, and some other sort of nebulously named entities here. Now, one thing we'll see, that with every agent who's mentioned, we have what are called the mentions, or the instances, if you like. These are the text regions that refer to that entity. So Michelangelo signs off as Michelangelo, but he also refers to himself as myself, my, me, I, and so on and so forth. We can click one of these and we can go to the agent screen and we can look into that as well. The next tab is called Statements, and so the statements we have here are statements of definition or trait. Now, it's a little bit cryptic to read, but I think we could make sense of this as saying that the statement is saying that Michelangelo, according to Michelangelo, the entity that's named certain envious and rascally persons has the trait of being evildoers, and we see there's a few other traits as well that he's attributed to them. So these are particular traits that Michelangelo has assigned to this group of people. And I've captured them here, and a couple of reasons. One is that we can come back to this later on. We can say, well, who else has he defined in his output as being a scandalmonger or an evildoer? Let's get all of those entities and view them together. Or if we choose to put these types into a hierarchy, we can come up with ancestor types. We can say maybe an evildoer might be a kind of criminal or a villain or something, and we could find other kinds of evildoers that might fall under the same category. So we can connect entities that way, sort of semantically. Now if we click one of these, this will take us to the screen for the statement, which was called a claim. And we can see it's evil livers. We can see the actors or the agents involved. The main subject is certain envious and rascally persons. They are evildoers according to Michelangelo. So there's a quasi-grammatical RDF triple-like kind of structure to this. We can see the text where that statement links back to. So we have sort of full transparency, and we can see here in the kind of greyish blue underlined text here where those trait statements are. Now, going back to the agents, it might be interesting to look at one in particular. Let's say we looked at the entity of Rome. Now, I won't go into every possible tab here, but I wanted to show you what what the graph database brings to this. Once we annotate references to Rome and we combine it with that syntax layer or stratum that I mentioned earlier, we can do a multi-dimensional query, and we could say, for example, I would like to search every sentence in every text where Rome occurs, and I want to see any other agents who are in that section, and I want to graph them by frequency. So if we click that button and we wait a few seconds, we get a very crowded graph. We can scroll down for the text output. We can see that Michelangelo is the agent who appears most in connection with Rome, then his nephew, then Florence, Lodovico, Michelangelo's father, and so on. We can restrict this a bit, so we can say, well, this is searching every section in Codex. We could restrict it to, say, Luca Landucci's diary, which is not quite as complete as Michelangelo at this point, and mainly centered around Florence. So we're having some Michelangelo letters are wrongly associated with the Landucci section. So let's go to this next level here. We can see Charles VIII, the King of France, and Florence are mentioned the most in connection with Rome in Landucci's output. So that's something kind of interesting. Another thing we can do is we can switch modes here. We can say, I want to find syntactically linked agents. So these are agents in the same sentence who are linked in the dependency tree. That's generated by the Google NLP API. Now the NLP API takes the text, returns a bunch of parts of speech tokens, and includes a hierarchy of parts of speech tokens called the dependency tree or the morphology, and that is also represented in Neo4j. So we can query. We can say, well, given this agent Rome, find any syntactic connections to any parts of speech which correspond to other agents. So if we click that button, we get a different kind of output. We see, again, Michelangelo. We get Domenico Buonasegni. We get a cardinal who's the son of the Duke of Ferrara, houses in Rome, French soldiers who are marking the houses in Rome, the French army at a point in time. And we can switch that to the Michelangelo context. We get rather more. Again, Michelangelo figures the most because of his activity in Rome. Then his nephew, then a good friend of his, Vittorio Colonna, and a few other people. We can drill into any of these people, and we could see their syntactic connections as well. Another thing we can do is we can directly query the parts of speech tokens as well. So this list corresponds to parts of speech tokens which overlap with Rome. So these are guaranteed to return something. So if I click singular and search, it's searching the system for every singular reference to Rome. So I don't think there's any plural Romes, so we're going to find pretty much every reference to Rome. But we could say every third person Rome. And we have here, for example, so I write this merely to inform you that on Saturday last we arrived here in Rome. He ought to come to Rome and prophesy a little for these people here. So this is starting to get a little bit more interesting. So this here is marked up as Rome in the database, but the parts of speech layer has also marked up that word as being a third person token. We can see proper, the city, you can see adverbs, and we can see nouns. Quarrel at Rome. Now we can also query the dependency tree, the morphology. So this will show you the syntactic relationships that Rome is involved in. So we might say, let's find a noun phrase that is a syntactic subject of a clause that involves Rome. There was a quarrel at Rome. So it shows you the sentence in which it occurs, and it shows you the what I've called the scope here, which probably incorrectly called the lexical scope. I'm not a grammarian, but that term made sense to me. So we can search for all different kinds of syntactic contexts for our agents. We also have the ability to take this kind of information and visualize it in a chart. So we could find nouns that occur in the same sentences as Rome. We can find any kind of part of speech token that occurs with Rome. So we can see Rome, in, from, Buonarroti here. So we're giving you, although you might consider this to be a stop word, it's still interesting. It's telling you something of that the letters are about things happening in Rome, and that there's more in than there is to or of. So that's kind of interesting. We can also see, we saw statements relating to text before. We can see statements relating to our agents. So we can see this is what I call a statement of event. So we're stating an event, we're recording an event. We can see here, for example, the text reference is the French ambassador's return from Rome. We represent that as, according to Landucci, 4 French ambassadors arrived at Florence from Rome. The beauty of doing it this way is that every component of that statement is linked to an entity in the system, including what they are doing. So the type of the event, the arrival, is a node. Every agent there is a node, and we will be able to, I will plan to build visualization tools, maps, timelines, and so on, to enable us to see these connections directly. So these are fairly atomic or discrete events. They tend not to be too complicated. They are marked up in other ways, but the idea is to try and extract fairly simple events. You know, X does something to Y at place, Z at time. Because this is in itself is interesting. This is something that can be computed and can be visualized. We can see every text in which Rome occurs, and we can see the number of times in which it occurs. So we can sort that by most frequent to least. And we can also see the meta relations I was referring to before, which are user-defined relationships. So we have a contains relationship with a container, which is Rome, a contained thing, in this case the house of Michelangelo in Rome. And we can actually even link this meta relation back to a reference in the text itself to document where this assertion came from. So we don't have to just record human relationships, social relationships, genealogical relationships. It can be a relationship of containment or ownership. This is more apparent with someone like Michelangelo. So if we go to the house of Michelangelo, we might be able to follow the trail here. We don't have at the moment a connection to Michelangelo, so we can actually add one. So we have a dominant meta relation type and a subordinate. Now we have an existing relationship called owns. So the dominant party in this case is Michelangelo. So we would say Michelangelo. Let's do a quick search. Michelangelo Buonarroti owns the house of Michelangelo in Rome. We can assign date information to that relationship if it's relevant. In this case, I don't have a particular date in mind. So we'll just hit save. Now we have a connection to Michelangelo. So we had a connection from Rome to his house, and now we have a connection to Michelangelo of ownership. So then we can click through to Michelangelo. We can see that relationship reflected here. So might recall that before owner was highlighted, now possession is highlighted. So from Michelangelo's point of view, the interesting party is the other party, his possession. From the house's point of view, the interesting party was the owner. We can see a whole bunch of relationships here. We've documented every reference to anything Michelangelo owns, and these are sometimes very indistinct entities. They're not necessarily concrete things like a painting, a sculpture, a house. It can be something quite broad. In this case, I've documented anything of Michelangelo's that Leonardo da Buonarroti has access to. Now, why would I do that? That is because it's a specific it's a specific idea that Michelangelo brings up in a letter. He talks about Leonardo, how he should treat the things that Michelangelo owns. So we can go back here and we can see, and thou art to do this with anything we possess. So it's something in Michelangelo's mind, so it becomes an entity in Codex. So if we go back to Michelangelo as an owner, Michelangelo is quite interesting because there are a large number of relationship types, and this might be something worth drilling into in another video, as would perhaps these statements. But I wanted to show, before I conclude this, an interesting case of where multi-dimensional annotations can lead you to sort of unexpected results. So if we look at a part of speech token which overlaps Michelangelo, something that might seem a little bit odd is second person, because this text corpus is Michelangelo's correspondence. He refers to himself naturally in the first person: I, myself, me, mine. A couple of times he refers to himself in the second person and the third person, and he might be referred to in other texts as the third person. Now, the second person is an interesting one, because if you think, what would it mean for him to refer to himself in the second person? Well, let's have a look. We have, looks like a quotation. Essentially, it's Michelangelo talking about himself from the perspective of another person. So he's quoting here about his relatives. We have more care for your person than for your property. If thou hadst loved me in very truth, thou wouldst have written to me after this manner. So we can find some interesting situations using these parts of speech tokens. Essentially, this information is for free. This is not annotated by humans. It's just something, you can click this button, generate syntax. You can generate all of these tokens here. Incidentally, if you click the checkbox corresponding to the part of speech it highlights the relevant words. Something you might notice is we've got English language, we've got Italian language as well. There's the capability in the system to generate syntax for the entire text, which is mostly English, but there are a few Italian words and sometimes there are Italian phrases. So you can also highlight an Italian word, click the syntax Italian button, and it will call the NLP API. It will generate Italian syntax information and store that. And that information will overlap. In fact, it hasn't been done for Marcelino, so I will do that here, and we can see this at work. Now if we select that, we'll see a part of speech, a sentence, or what it thinks of it as a sentence, so we can see token ID and so on. So if we hit save, we've also had the lemma, which you might not have seen there. So we have Marcelino now. Now if we, a noun has come up for Marcelino. So we can combine, we can have an English language syntax for the dominant language in the text, and then we can go and essentially mask individual sentences, phrases, words, names, and that information will be stored as overlapping annotations. And you can imagine perhaps it would be interesting to do queries based on Italian parts of speech in primarily English text as well. Could be quite interesting. That's, I think, where I'll finish today. If anyone has any questions, if they'd like to see anything in particular, if they got this far in the video, I would love to hear from you. There's a lot more to do in Codex. This is a passion project of mine, which I'm doing by myself. All of the programming, design, data entry, and annotation. So it does take a while to get there, but I'm hoping to get a front-end public version of this published within a few months, where people can interact with these texts without having to deal with a complicated interface. But if anyone is interested in using this in their own projects, or they'd like to have a play with it or give feedback, I would be very happy to hear from anyone, and I will put the details in the video description. Thank you.